Numerical number 22, Kinematics 3. We can draw the diagram an inclined plane on which a body falls freely under gravity from a height h, capital H. This is the point A, B and C. AC is the inclined plane on which a body will strike. A body is at the point P and it falls freely under gravity and it strikes at this point. That means at the point Q, and it will be moving horizontally after striking the inclined plane. This point is P, from which the body starts to fall from rest, and this is the point Q at which the body strikes the inclined plane AC, and along QR the body will be moving horizontally after striking the inclined plane. Initial velocity U1 at the point P was 0. U1 is 0 because the body starts to fall from rest, and initial velocity after striking the inclined plane is U2, which acts horizontally parallel to the base of the inclined plane BC, and we can draw a normal from the point Q, and that normal is Qn on the base BC or on the horizontal line BC. Capital H is the height from which from the point P. Capital H is the height from the point P. The body falls. Small h is the height of the point Q. Small h is the height of the point Q. Here capital H, remember that capital H is the height of the point P, not the height of the point A. So capital H is the height of the point P from the base or from the horizontal. Given U1 equals 0, that is initial velocity at the point P. Initial velocity of the body at the point P is 0, and the time at the point P is 0. The time in which the body reaches to the point Q and strikes the inclined plane is T2, and in the absence of the inclined plane, the body will travel from Q to N and strikes the ground at the point N at the time T2. That is total time taken by the body from to travel from P to N is what? T1 plus T2, and according to the question, this time, these two times will be maximum. Sum of these two times, T1 plus T2 will be maximum. And also we have to find h by h. What will be the ratio of that two heights, h and h by h? Small h by capital H equal question mark. Small h is the height of the point Q on the inclined plane from the horizontal line, and capital H is the height of the point Q, not height of the point A. Capital H is the height of the point P from which the body starts to fall. And at the point N, the total time is T1 plus T2. Now, P is the point from which the body starts to fall with initial velocity U1, and it strikes the inclined plane at the point Q, and it will be traveling. What is the height of the point Q from the base of the inclined plane BC, which is small h? And the body travels from Q to N in time t2. That is, interval of time from Q to N is t2 in the absence of inclined plane. Actually, the body is traveling along QR, but in the absence of inclined plane, the body will be traveling along Qn. Now we have to find small h by capital H. Using the equation S equal ut plus half at square. S equal ut plus half at square. Between the 2 points P and Q, between the 2 points P and Q, P is the point from which the body starts to fall under gravity, and Q is the point at which the body strikes the inclined plane AC. Using S equal ut plus half at square between P and Q in vertically downward direction. In vertically downward direction, we get H minus H. The displacement will be capital H minus H. H minus H equal initial vertical velocity is E1 T1 plus half bracket opened. In place of acceleration A, we can write plus G, because the body moves downwards. That's why we have to consider plus G, not minus G, into T1 square. From the point P, the body starts to fall with initial velocity E1, and the distance of the point Q from P is H minus H. This is H minus H. This is the distance the body travels from the point P to Q with initial velocity E1 equal to 0. Or comma H minus H equal 0 plus half G T1 square. Since E1 equal, where E1 equals 0, initial velocity of the body at the point P was 0, that is E1 equal to 0. Or comma T1 equal root over 2h minus h whole divided by g. H minus small h divided by small g. This is the expression of time T1 in which the body travels from the point P to Q. T1 equal root over 2h minus h divided by g under square root, and this is equation 1. and t1 is the time in which the body falls from the point P to Q and strikes the inclined plane at Q. Again, using the same equation, S equal ut plus half at square. Using the equation S equal ut plus half at square between the point Q and N, we have to assume that in the absence of the inclined plane, the body will be traveling along Qn from the point Q to N. From the point Q to N, between the 2 points Q and N. Q and N. In vertically downward direction. That means we have to assume that if there is no inclined plane, the body will be traveling from Q to N in vertically downward direction. We get small h, in this case the displacement will be small h and interval of time is t2. So u2y t2 plus half under bracket plus g, because the body moves downwards. If the body moves upwards, then we have to consider minus g, plus g t2 square, where the vertical component of the horizontal velocity u2 is u2y, which is u2 cos 90 degree. The velocity of the body after striking the inclined plane from the point Q is u2 in horizontal direction. u2 is the velocity in horizontal direction after striking the point Q on the inclined plane, and the component of u2 in vertically downward direction is u2y. According to resolution of a vector, the formula of resolution of a vector, u2y acts vertically downwards. This is u2y equal u2 cos 90 degree, because u2y is perpendicular to u2. That's why you have to write cos 90 degree. So therefore u2y equal to 0. So write down all the terms which is written in white color, not in blue color, in your copy. And this displacement from the point Q to N is what, h minus h. Not h minus h, it should be small h. So small h is equal to 0 plus half g t2 square. Therefore, or t2 equal root over 2h by g. t2 is the time in which the body travels from the point Q to N in the absence of the inclined plane, not the total time in which the body travels from P to N. So T2 is the time in which the body travels from the point Q to N in the absence of the inclined plane, which is equation 2. This is equation 2, T2 equal to root over 2h by g. Root over 2h by g. This is the time in which the body will move from the point Q to N in the absence of the inclined plane. T1, again we can write T1 is what? T1 is, this is the time in which the body falls freely from the point P to Q under gravity. Now the total time taken by the body to travel from P to N is given by T equal T1 plus T2. Therefore, T equal, putting the expression of T1 and T2, T equal root over 2 by G bracket open H minus H whole to the power half plus H whole to the power half. If the total time T is maximum according to the given condition, the total time T is maximum, then dt by dh equal to 0. That is derivative of the time T with respect to the height of the point Q from the horizontal line h, small h, is 0. Or comma ddh, now putting the expression of T, root over 2 by G, second bracket opened, h minus h whole to the power half, h minus h whole to the power half, plus small h whole to the power half. Second bracket closed, third bracket closed, 0. Or comma, root over 2 by G is constant, we can bring root over 2 by G outside the third bracket. Now we can differentiate h minus h whole to the power half and h to the power half. ddh h minus h whole to the power half, bracket closed, second bracket closed, ddh first bracket h to the power half, bracket closed, third bracket closed, equal 0. Or comma, root over 2 by G. Now if we differentiate h minus h whole to the power half with respect to small h, then we get using the formula of ddx of x to the power n, half h minus h, half minus 1. Now in place of h we have h minus h, that's why you have to multiply the result with ddh of h minus h, ddh h minus h plus half h to the power 1 by 2 minus half, bracket close, equal 0. Or comma, one by 2 h minus h minus half, second bracket open, operating ddh over h and h, ddh of capital H minus ddh of small h, second bracket closed, plus 1 by 2 h to the power minus half, bracket closed, 0. Or comma, 1 by 2 is constant, so we can bring outside, we can take common half outside the bracket, h minus h to the power minus half, second bracket open, 0, capital H is constant, that's why ddh of capital H is 0 and ddh of small h is 1, plus h to the power minus half, bracket close, 0. Or comma, h minus h whole to the power minus half into minus 1 plus h to the power minus half equal to 0. That is minus h or comma h to the power minus half equal h minus h, capital H minus small h whole to the power minus 1 by 2, or h is equal to h minus h, or capital H by small h minus 1 is equal to 1, or comma capital H by small h equal plus 2. Therefore, small h by capital H is equal 1 by 2. Equal 1 by 2. So this is the value of the ratio h by h for which the body will take the maximum time to reach the ground from the point P to the point N. H by h is equal 1 by 2. That is the value of the ratio of the two heights is 1 by 2. In this case, the total time to travel from the point P to N, to travel from the height capital H to the ground in the absence of the inclined plane will be what? H by h is equal to 1 by 2. H by h is equal to